Continuing with some examples on graphing sine, let's take a look now at this example here. And we need to identify information, namely period. I think I did that in blue last time, so it'll be consistent. So our period here, well, let me back up a minute. Let's do amplitude first. So let's take a look. A here is -1/2, and B again is 1. There's no number other than 1 there. So now our amplitude, which we can get from A, so our amplitude is equal to 1/2 absolute value of A. And now in terms of period is 2 pi over B, which is 2 pi over 1, which is 2 pi, which is similar to the example that we did just before this. So again, we're going to divide our period, 2 pi by 4, which gives us our pi over 2. And just like before, that pi over 2 is going to be the increment that we're going to add to our starting x value in order to get all 5 of our key x values. Again, similar to the example we just did, we don't have any phase shift. So we're starting with our x is 0, which we've seen before. Then we're going to add our increment of pi over 2 to get our next x value of pi over 2. Pi over 2 plus pi over 2 is 2 pi over 2, or pi. Adding pi over 2 again, this is what we did in the previous example, 3 pi over 2. And then last but not least, 3 pi over 2 plus pi over 2 gives us 4 pi over 2, or 2 pi. So there are our 1, 2, 3, 4, 5 key x angle values. Now for our sine values of each of these, we know that we're going to start with 0, 1, 0, -1, and 0, because the sine of x here, we're looking at sine of x, sine of pi, for instance, is 0. So that's where we're getting these values from. Now, here, we have a -1/2 in front. So you might recognize from pre-calculus, remember from pre-calc, when you have a negative sign in front, that's going to be a reflection involving the y. So our function is going to be rotated over the x-axis. And we'll see this when we multiply each of these sine values by this -1/2. Similar to before, our zeros stay the same because 0 multiplied by anything is 0. And now 1 times -1/2 is -1/2. And -1 times -1/2 is +1/2. So these are now the pairs that we are going to graph here. So let's start. We have x0, y0. So there is our 0, 0. Now proceeding on, we have pi over 2. And for pi over 2, we're going to be graphing 1/2. So notice, instead of normally going up, we're going to be going down now to -1/2. There's our reflection. Continuing on, at pi, we have the 0 value. For y, 3 pi over 2. Here, we're at 1/2. And then finally, at 2 pi, we're at 0 again. So connecting these dots, there is our function, and it's reflected over that x-axis because of this negative sign. Now, taking a look here, we were told what we've done here is we have graphed an entire period between 0 and 2 pi, but what we were asked to do was to graph this between -pi and 3 pi. So we're going to have to continue our graph here. So from this point, we're going to go up to 1/2 here, and then back down to pi here. We're just going to continue the pattern. Then on this side, we stopped at 2 pi. We have to continue to 3 pi. So from here at 5 pi over 2, we would go down to the 1/2, and then we would come back up again at this next increment to 0. So there is our period, but then we've extended the graph. I've done this on Desmos so that you could see how the graph we came up with compares to our regular y is sine of x. So we can see, taking a look between 0 and 2 pi here, we have the same key x values. At 0, pi, and 2 pi, there are our x-intercepts. And now at pi over 2, in our sine of x, we had the maximum of 1. But in the function we just graphed, we have a minimum at negative 1/2. So we reflected and we also shrunk, so to speak, our graph. And then here at 3 pi over 2, in our regular sine of x, we have a minimum at negative 1. And in the function we just graphed, we have a maximum, again, because of the reflection, and it's at 1/2 because we shrank the graph. Okay, so continuing on for this next example, we have this situation here where, again, let's get started by identifying our A, B, and so we have A is equal to 2. So our amplitude here is equal to 2. B, now we have some different information here. B is 1/2. So we're going to have a change in our period. So period is equal to 2 pi over B. And in this case, our B is 1/2. So we have to divide 2 pi by 1/2. So if we unpack this into a division, 2 pi divided by 1/2 is the same as 2 pi multiplied by 2. Remember, we flip. In division, we flip the fraction, and then it's a multiplication problem. So we have 2 pi times 2. So now, I'll put this over 1 so you can see I flipped it. So now our period is 4 pi. So instead of our period being the normal 2 pi, our period now, it's going to take us a full 4 pi to go through one cycle. We need to take this 4 pi, let me come over here for room, and 4 pi, we're going to divide this by the 4 to get pi. That's our increment, because remember, we're going to need that increment to find our key x value. So there is 4 pi is our period, and pi is the increment that we're going to use. So once again, we're going to start at 0 here, and now we're going to be adding pi. So 0 plus pi is equal to pi. And then here, we add another pi. Pi plus pi is 2 pi. Add pi again. 2 pi plus pi is 3 pi. And finally, 3 pi plus another pi is 4 pi. I mean, I haven't continued to write that little addition. I think it's straightforward enough to see. Add pi, pi, 2 pi, 3 pi, 4 pi. Now, in terms of our values here, our sine function, these are going to be the same as they were in the other example. This is going to be, I can't remember what color I used, so I'm just going to use blue because I like blue. So this is going to be our 0, 1, 0, negative 1, and 0. Because of the way we've chosen these key x values, we know that this is going to be the information here for the sine function. So we could prove it if you want to see where we got these from. So here, for 2 pi, sine of 1/2 x, if x is 2 pi, 1/2 of 2 pi is pi, and the sine of pi is 0. So we could go through and substitute all these x in here, but we don't need to because we know what they will be. So now let's continue completing this because we have this 2 here and we need to multiply each of these values by the 2. So as before, the zeros stay the same. 2 times 1 is 2. 2 times -1 is -2. So let's go ahead and graph these. We have 0, 0. And now at pi, we are at 2. We're up here. At 2 pi, we're at 0. At 3 pi, we are at -2. And at 4 pi, we're at 0. So when we connect these, there is one period. It's a little lopsided, but there is one period here. Now, looking here, the statement says graph between 0, well, we started at 0, but now this says continue this until 8 pi. So 4 pi, 5 pi, 6 pi, 7 pi, 8 pi. So we need to continue this pattern. So here, for the next pi interval, we're going to be up at 2. So we're going to continue up here. Then at 6 pi, we're going to come back down again to 0. At 7 pi, the next pi will be down at -2. And then 8 pi will be back at 0. And then, of course, this would continue, but this is what we were requested to do. So now, taking a look at this graphed on Desmos, we can see that here is our regular y is equal to sine of x. Between 0 and 2 pi, there's our period. And we can see here with this new function, y is equal to 2 sine of 1/2 x, we've changed our period. So instead of having one period between 0 and 2 pi, we found our period was 4 pi. So looking here is 4 pi, so we can see for this function that we just graphed, we need 4 pi to complete one cycle, and also our max and mins have changed because the amplitude has gone from 1 to 2.